IRIS is the new VAO tool for the creation and analysis of the spectral energy distributions of the astronomical sources. In this demo, I will show you how to create an SED by integrating different sets of photometric points, hereafter generically called segments, from different observations, regions, and features, using the SED Importer. As an example, we will consider the quasar 3C273 and will build the SED of this source using Fermi observations from the 2FLG, the second-year Fermi catalog, all multi-wavelength observations available in the literature data retrieved through the NEDSED service, and fake ALMA data. Let's start by creating SED. We can click on Load SED from the SED Importer and give a name to the SED, for example the name of the source itself, 3C273. This window contains the general information about the SEDs we are going to create, the list of the different segments that will be added to the SED, and some information about the source. For example, we can retrieve the coordinates of the source attached to its name by entering the name of our quasar in the name field and clicking on Resolve. Now it's time to start adding data to the SED, and we'll start add a segment represented by Fermi data containing a file sitting on our desktop. This file contains a column-oriented table of 5 photon flux density measurements in discrete energy intervals. By clicking on New Segments, a new window pops up, where we can select the path of the file containing the data on our computer. In this case, we can also set the format of the file we are about to load as an ASCII table file. Another click on Load will trigger a new window called Import Setup Frame, where we ask to provide the SED Importer with a minimal set of information about the file we are trying to import. The SED Importer requires such information to correctly interpret the data contained in the file. We are firstly asked to indicate the column of the table containing the spectral coordinates of the flux measure. In this case, we will pick energy. So we will select energy, and the SEM units megaelectron volt. In this case, then we have to indicate the column containing the flux measurement, be them flux, flux density, photon flux density, or AB magnitudes. And we will pick the photon flux density, expressed in the photon per second per centimeter square per hertz. If the error and the flux measurement are available in the file as separate column, we can select the symmetric column option in the Y arrow frame, and then pick the column containing the errors in the drop-down menu. After providing all this information, we can also edit the publisher field, which is now set to unknown, just to make sure that we will remember the origin of this data. So in this case, we will just edit the field, putting Fermi. Now we can click on Add Segment to SED. The first segment of the 3C273 quasar SED containing 5 data points from our Fermi data will appear in the main SED window. Now we want to show how a new segment can be sent to the SED Importer from any interoperable tool. We can imagine that our future ALMA data for 3C273 have been retrieved from a generic VAO service through, say, the VAO portal or TopCat. In this case, we will consider TopCat. TopCat is a tool for handling visualization and manipulation of tabular data. We have uploaded our file, which is a column-oriented table composed by 5 columns. We can seamlessly send the data containing this file to the SED Importer just clicking on this tower here. A new importer setup frame will automatically pop up in the SED Importer to collect the fundamental information of this new segment. So we will select the frequency as x-axis, expressed in gigahertz, the flux density, expressed in Jansky, and also in this case we can indicate a symmetric column containing the error estimates for our data points, flux density inserted. Just to make sure that we will remember that these are fake ALMA data, we can edit the publisher field with ALMA fake, and again add the segment to the SED. Now it's time to retrieve all the multi-wavelength observation of 3C273 available in the astronomical literature. So again we can click on New Segments. This time we will select the option Get an SED from the NED service. The target name is automatically filled, so what we have to do is just click on Import NED SED. Here we are, a third segment composed of almost 460 data points has popped up in the list of segments. So at this point our SED is complete. We can save the SED to a file in VAO table format by clicking on Save SED, browsing our desktop for the path of the file, give a name to the file and just clicking on Save, and again Save. But we can also open the SEDs in the iris, so we can minimize the window containing the SED. Go back to the SED Importer and click on Launch Iris. So iris has opened. Going back to the SED, we can maximize the SED window, and then just clicking on Broadcast SEDs, we will see that in a few seconds the plot with default visualization option or the SED we created will pop up in the iris window. Here we are. Now we're ready to start analyzing our SED.